need your TI-84 opened up, ready to roll. Okay, so on all of these problems, what you're coming across is you got to get the variables down to just one. So you usually have to rewrite one in terms of another. All right, so you're told that a rectangular plot is enclosed by 180 meters of fence. So here's our drawing. And so what that tells us is it's on three sides. The fourth side is a stone wall. All right, so we just need to use three sides to get 180. So from this, I know that if I take W and I add the length and I add W again, I'm going to get 180. So L plus 2W is going to be 180. L plus 2W equals 180. All right. So it says, find an expression for A, the area in square meters in terms of W. All right, so we know that area for a rectangle is length times width. So we're going to start with that, and then we're going to rewrite it so it just has W's in it. Okay, so the area in terms of W equals length times width. And I'm going to have to take out the L and replace it with 180 minus 2W. Any questions why that is? So that the only thing I have in this equation is W's. Yeah, because I can't solve something that has two unknowns in it. So that becomes my function. So this notation here, guys, just means the area in terms of the width. Plug in the width, this gives you the area. So that function notation just means area in as a function of width. Yes, it's exactly like f of x. It's exactly like f of x. Okay, so that just means area as a function of width. It doesn't mean A times W. Does not mean that. It's just notation. Okay. And then I can simplify that by distributing the W. And I'd end up with 180 W minus 2W. And usually you write that in order. You put the 2W first. You go quadratic and then linear. So negative 2W squared plus 180W. All right, so now you got A in terms of W. All right, it says find the dimensions of fencing that yield an area of 3,600. Okay, so all we're going to do is replace A with 3,600. And solve it. So I'd have 3,600 equals Yes.
So then do you move the 3,600 and square it?
Well, you're going to move the 3,600, and then you're going to try to either factor it or complete the square
That's what I meant.
or quadratic formula it. Well, you could. I'm going to factor out the negative 2, so I end up with this, and now you'll see that this trinomial we can factor. So 1,800 would factor into negative 1,800. And that's got to add together to be 90. Now, let's make sure I didn't lose the negative somewhere. So when I divide that, this should be minus. And this should be plus. So negative 60 and 30. All right, so based on that, possible answers would be 60. Okay, so the question says find the dimensions. So one possibility would be 60 meters by, okay, to get the length. The length is equal to 180 minus 2w. So that is going to be 180 minus negative for the 60.
Oh, wait, just hit it.
Right. Well, because also if you're finding length, it would have to be a positive number. So if I plug 60 into here, I'm going to get 180 minus 2 times 60, which would be 120. So this would be 60 by 60. Or if the length was 30, 180 take away 2 times 30 would be 120. So either one of those would give you 3,600 square meters. Okay, questions on that? Anybody at home? Any of our listeners coming in today from Palau? Any of our Palauan brothers and sisters have a question? No? Okay. We're broadcasting to Palau today. Palau is a very small island in the South Pacific. My old principal is now like in charge of it once she retired from being a principal. So I stream classes out there. Nuts. Because it's like 4 a.m. there.
Or like, do you hear about the vaccine?
I did.
Oh, because of you.
No, my vaccine's still on pause. Yeah, they're still trying to figure out why the guy's spine swelled up.
Looks like
I know. I was really ready to step up. No, nothing. Well, they can't do anything. They can't even test you. I mean, they can't give you the vaccine until they find out why the guy got the swollen spine. Darn. I put my money on the Brits on this one because this vaccine came out of Oxford. I figured Oxford's got their act together, you know, if anybody's going to do a good job. No.
Well, then if your spine swells up, then I guess we know.
Yeah, no, I don't really want that to happen. Okay. All right, so now find the dimensions of fencing that maximize the area. Okay, so your area formula is this, AW, and you could use f of x just the same. Negative 2w squared plus 180 w. So if we were to graph this thing, okay, it would have a y-intercept of 0 because there's no constant in this. And it would open down. So it would look something like that. Okay, this would be the width. And what would the y-axis be? No. When you plug W into this formula, what does it give you? Right, your y-axis is going to be your y value on this parabola is going to be the area. Okay, so if you were looking for the dimensions that give you the maximum area, where are you going to look on the parabola? Yep, you're going to look to the vertex. Okay, so the dimensions, we want to find the vertex. The x-coordinate of the vertex is going to be the width, and the y-coordinate is going to be the area that we get at that width. All right, so this is just in standard form. So on this summary that I gave you, when it's in standard form, to find the vertex, you're going to do the axis of symmetry, and then you're going to substitute it into the equation to get the y-coordinate, okay, which in this case would be the area. So we're going to use the opposite of b divided by 2a. We're finding the vertex. You could, but it's probably quicker. Well, I know it's quicker to do it by hand in this case. So if we were going to do the vertex, okay, this number is going to be the opposite of b divided by 2a. Okay, so that is negative 180 divided by 2 times negative 2. So that is 45. Okay, so I now know that that number right there is 45. And now I want to get that. Yep, that's the x. So this is 45 meters. That's telling me the width is 45. And now to get the area, we plug 45 into our area formula. So we have negative 2 squared plus 180, and we drop in 45. Do that on your calculator, and that gives you 4,050. Okay, that's the area. So this is going to be square meters.
Y by X to get the.
Yeah, you could. Yep. So I could get my length two ways. I could do that, or I could just go back up here. And I know the length is 180 minus twice the width. Yep. My answer is make it 45 meters by 90. And then the last part is what's the maximum area? This is going to be the y coordinate of the vertex. So we got that was the. Okay. Questions?
Wait, why doesn't this look?
What do you mean? It doesn't look like it should? Okay, let's take a look. See. You sure you typed it incorrect? Negative 2x squared plus 180x? Y equals negative 2x squared plus 180x, correct? Okay, and we're going to get rid of that 18 there. That. Okay, graph it. All right, so you got to change your window. Okay, now there used to be a function on here called zoom fit. Let's try that one. There you go. Almost. All right, so at least I can see it a little bit better. I hit zoom fit. Now I got to go way to the right. Okay, because this value right here, folks, that's negative width because it's negative x values. So that doesn't make any sense. So I'm going to go window. I'm going to change my x minimum to 0 because I can't have negative width. And I'm going to guess 100. Let's see if that. Okay, so I got that part in. Now I just got to get the vertex. So I got to go higher on the y's. So we'll go y minimums we don't need because you can't have negative area. And y max, I could go to maybe like 500. Nope, I got to go to like 5,000 because I know the max area was 4050. Okay, graphic. There. Yeah, that looks right. Then if you did it on your calculator, which we're doing on the next problem, and you went second calc and go to number 4 and get your vertex that way. Left bound, put it to the left of the vertex. Right bound, put it to the right of the vertex. Guess, put it at the vertex or close to. And we get, if you rounded that, you'd get 45. Okay. So it didn't look that way just because of the scale. Okay, question.
If we had 45,
45 meters for the width.
that on paper is no. On the calculator, or calculator,
49.99999, 40, it was 44 point, yeah. It's just because of the way the program's calculated, I would imagine. That's really 45. It has to do more with the internal workings of the calculator than anything.
not even.
No, you don't have to worry about it. That's 45. All right. So you're throwing a ball up in the air. Okay, classic projectile problem here. All right, when you're looking at a quadratic can be used to model the height of anything shot up in the air because it's parabolic. Okay, what these numbers are, if we had the formula right here, this is 1/2 the acceleration due to gravity. Gravity is 9.8 meters per second squared. Okay, so 4.9, that's where that comes from. That doesn't change unless you go to another planet. All right. The 24, this is known as the initial velocity. So this is V, we call it V sub O, initial velocity. And the 2 is the initial height. Okay, so this is somebody's throwing it. So this person, when they let go of the ball is 2 meters above the ground. So like 6 feet. Ball 6 feet above the ground when it starts. Okay, write down the initial height of the ball. So that's always going to be the same as the y-intercept. And the y-intercept is the value of c, which is in this case 2. So our y-intercept is 0, 2. So the initial height of the ball, h sub 0, is 2. Okay, now find the maximum height. So you could do this one just like you did the last one, opposite of b divided by 2a, or you could put it in your calculator like it's suggested here and use the maximum function. Okay, now when you put this into the calculator, on your graph here, what does the x-axis represent? No? No? Now look, if you look right here, it'll tell you. Right, so what's there, that's what goes on your x-axis. And then h of t, the whole thing, that's your y-axis. So when we get the numbers up here, the number that we get here is seconds or time, and then the number we get over here is the height. So when we do the vertex on our calculator, this is going to be seconds, and this is going to be the height at that number of seconds. Okay, so you just type that in and then go second calc and pick your vertex. You could. I don't think, I know. You could just do that. But I just wanted to be sure that everybody knew how to do it on here. But yeah, you're absolutely right. Okay. Looks like anything. Zoom, fit. That would get me in the ballpark. Well, that's the negative part of it. Okay, so all right. So I just got to go higher up, and I don't need to worry about negative time. So that can be 0. X max, at 10. Go higher here. Too much. Say 50. There we go. Okay, then second calc. Max. Now I'm going to move it to the left of the vertex. Left bound. Whoops. There it is. No, I did that wrong. Second. Okay, left bound. Boom. Right bound. Enter. Yes. Enter. There we go. All right, so if I rounded this to 3 sig figs, this would be 2.45 seconds. And my height is 31.4 feet or meters. So the answer is just the y coordinate. Not the, you don't give the coordinates. You don't give the time, you just give what the maximum height is. Okay, now the next one shows you an application of where you've got an inequality. So find the length of time where the ball is at least 18 meters high. So what you're doing is you're taking this equation here, this quadratic, you're gonna eventually, but here's the equation that you'd have to solve. At least would be greater than or equal to 18. Well, just the other day we did quadratic inequalities. So if I was doing this as a quadratic inequality, I would solve this inequality. So all that stuff that we did where we do the sign chart and we see where this graph is above or below. So I would guess, we're not going to do it. I'm just going to write down the steps. Okay, you would find the x-intercepts by the quadratic formula. Pardon me? Not on this. No. Because you want to find, wait a minute. No. What I want to do is because it's not asking me for the values of t such that I use the discriminant when I'm trying to figure out if it's got 2 real roots or no real roots. This one is just an inequality. So you'd find the x-intercepts by using the quadratic formula. Okay. And then you would make a sign graph. And you'd be looking for where the sign graph is positive. Look for positive intervals. And then that would tell you, okay? But to speed it up, we're going to do it on our calculator. Okay, so to do this on our calculator, all you got to do is set up another equation that's equal to 18. So go back to your calculator, the y equals, and make the second equation equal to 18. And graph it, and it looks like that with a line through it. Okay, now where on this graph is the parabola at least 18 meters high? Where would I be shading on this parabola? Okay, that's, yeah, the red line and up. So this portion right here is where the parabola is at least height at least 18 meters. All right. Well, a couple of weeks ago, we graphed quadratics and lines for this very reason. Okay, so all you got to do on your calculator is use which function on the calc menu? Look at those values. Yes.
I want to say 0, but it's not on the 0 line.
No. So what I want to find, whoops, I want to find what this x value is. And I want to find what this x value is. We know the y values are 18. We know this other y value is 18. So how are you going to find the x values? Exactly, you'd use the intersect function. Okay, so I'm just going to choose number 5, intersect. What curve? Well, I want the parabola, and I want the line, and now move it to the intersection. Right there, and hit enter. 0.796 seconds. 0.796. Okay. All right. How to do it? Okay, so I'm going to do it for the other intersection over here. Go second calc. Then you go to number 5. Now, if this is just asking what graphs do you want to find the intersection of? Well, I want the intersection of the parabola, which is the first curve, so I hit enter. The other curve that I want is the line. It's highlighted now. So I hit enter. Now move the cursor to the intersection you're interested in and hit enter. Yep, it'll find the intersection for you. So that's 4.10. So that's the other amount of time. This would be 4.10 seconds. So the question was asking how long? This was 0.796. Okay, so the length of time, I'm going to subtract those two. That's going to be 4.10 seconds minus 0.796. Answer is 3.30 seconds. And now the last part. Find the amount of time elapsed when the ball hits the ground. So we want to find this. So which function on our calculator gives us that? It's zeros, right? So now go second calc, and I'm going to choose 2. Okay, whoops, second calc 2. Okay, I want the left bound to be before the x-intercept, right bound to be after it, and the guess to be right at it. There it is. That would be 4.98 seconds. Okay, so this was 4.98, and the height was 0. All right, we'll stop there. We got this one more example to do. This is going to be Thursday's assignment, but you pretty much know how to do 3 out of the 4 problems. So if you don't want to wait till Thursday night to do all of them, you have the notes for 1, you have the notes for 2, and you have the notes for 5. And then on Monday, we'll do an example like number 4. Yep, say, see you later. So, Control, Alt,